Today we're going to be lecturing on Chapter 9, Production and Operations Management. I'm going to skip ahead a few slides. Many people think that we don't produce much in the United States in terms of goods, and that is correct. We are producing less than we used to. But as you can see, some areas actually do have economic growth, while others are declining, such as autos. Part of the reason why we produce less is because of technology, as we've talked about. Fewer workers are needed. However, we still do make things in the United States, as this slide can show you. Although we don't make as many things in the United States, we are in the middle of the service era of the United States business era. And you can see that almost 85% of jobs in the United States are in the service sector. Not only do we have the most jobs, they're the highest paying jobs. There are low paying jobs in the service sector, but also high paying jobs, as you can see from the slide. And we are still the leader in certain things, such as biotechnology, nanotechnology, etc. So the slide points out several ways that we can maintain a competitive advantage, something we've talked about before. We talked about competitive advantages. If you recall from a few moments ago, today's chapter is called Productions and Operations Management. Let me give you the definitions of both production management here on this slide and operations management on the next slide. Production simply is the creation of goods using land, labor, capital, entrepreneurship, and knowledge. You should know that by now as the 5 factors of production that we talked about way back in Chapter 1. Therefore, productions management is all the activities managers do to help create goods and services, by the way. We make goods and we provide services. The second part of today's lecture will focus not on production management, but rather operations management. Operations management is a specialized area of management that converts or transforms resources into tangible goods and intangible services. In essence, class, this is really important. Productions management is part of overall operations management. So in essence, productions management is a subset of operations management. So operations management deals with everything, not just the production of goods and services, but everything, including but not limited to such things as inventory management, quality control, scheduling, and follow-up. Let's talk about productions management first. In class, until I say so, we'll be talking about production management, and then when we get to operations management, I will let you know. As you can see from the slide, this is the production process, a visual representation of the production process. In essence, we take our inputs, which is our 5 factors of production: land, labor, capital, entrepreneurship, and knowledge, and we run it through a control process through such things as planning, routing, scheduling, follow-up, etc., until we get the output, either the tangible good, the intangible service, or some even idea. Let's talk a little bit about form utility. Form utility, simply put, is the value that producers add to materials in the creation of both finished goods and intangible services. So think of it this way. Let's take, for instance, a butcher who cuts up pieces of meat. The butcher produces various cuts of beef from a cow, such as a filet mignon, a porterhouse, or a New York strip. In essence, that butcher is creating form utility. The butcher creates value to materials in the creation of finished goods or services. I could just sell you a cow, but unless you really have the butcher The butcher then creates farm utility by taking that cow and cutting that cow up into various slices of beef. As you can see from the slide, this is regarding basic production requirements. And this came from Andrew Grove, who was the former chairman of the huge semiconductor company Intel. You may not have heard of Intel, but you've dealt with Intel chips in your computers and other technological devices. Here are his 3 basic production requirements. First, to build and deliver products in response to the demands of the customer at the scheduled delivery time, which means you got to get it there when the customer needs it. The quality level, number 2, the quality level has to be acceptable. It doesn't have to be the best, but it has to be acceptable. And third, number 3, to provide everything at the lowest possible cost. That's how you have production requirements. Let's take a little bit in time to talk about both process manufacturing and assembly process. And I believe that's Duff the Cake Guy. I have no idea who he is, but a lot of you guys do. Process manufacturing simply is the part of production that physically or chemically changes materials. So for instance, Duff would be very familiar with boiling an egg. Physically changes its components. So it goes from a regular egg to a hard-boiled egg. Assembly process production is the part of a production process that puts together components. So for instance, if you were a cook putting together a breakfast, you would assemble the eggs, the toast, and the coffee and other breakfast items, sausage, put together to make breakfast. Cars are made through an assembly process. All production processes will either be continuous or intermittent. Continuous processes are long production runs that turn out finished goods over time. So for example, think of a chemical plant that's running 24 hours a day. Whereas an intermittent process have production runs that are shorter, and the producer adjusts the machines frequently to make different or custom-made products. Think today of a furniture manufacturer. They're going to make lots of different pieces of furniture, not just the same thing. The key is to be productive, as Andy Grove said, to do things as quickly as possible. Look how many Krispy Kreme donuts can be made in a minute. So for the next several slides here, part of the issue is that over the years, we tried to make things at a low cost, which was the third thing that Andy Grove said, but making things at a low cost came at the expense of either quality and or flexibility. So in the next several slides, we're going to look at developments recently using technology that has helped make the US companies more competitive. First, we'll talk about computer-aided design and computer-aided manufacturing. Then we'll focus our attention on flexible manufacturing. Afterwards, we'll look at lean manufacturing. Then we'll look at mass customization. And finally, we'll look at a fifth thing that's not on the slide, robots. First thing we wanted to look at was computer-aided design and computer-aided manufacturing. Computer-aided design is the first step, and that's the use of computers or other technology in the design of products. This often leads to the second step, which is, the second component of computer-aided manufacturing. Here we use computers not just in the design, but now to actually make or manufacture the products. Keeping on number one, the uniting of CAD, computer-aided design, with CAM, computer-aided manufacturing, leads to computer-integrated manufacturing. That's the united of those two things. It's expensive, but look how much of the costs in time it can eliminate. So for instance, think of a 3D printer now. It designs and manufactures almost anything very quickly. Second thing we want to look at is what's known as flexible manufacturing. In flexible manufacturing, here we're designing machines to do a variety or multiple tasks or a variety of products. So as you can see from the slide, here the motor starter company Allen-Bradley uses flexible manufacturing to build motor starters. Okay, and so they can produce a lot of different types of products using just one type of machine. It's very flexible. Afterwards, let's look into what's known as lean manufacturing. Lean manufacturing just means the idea of less is more. Not so much that less is more, but less costs less. So using less of everything than in mass production. So lean companies that use lean manufacturing, look at some of the results. Half the human effort, 1/3 of the engineering effort, half the floor space, and they carry less inventory. It just costs less because they're being leaner. Fourth one we want to bring up is the notion of mass customization. Under mass customization, you are tailoring products to meet the needs of a large number of individual customers. So the idea is you're using, machines can make not just one thing, but a variety of things. The best example I can give you that is if you've gone to Magic Mountain or another type of fast food restaurant, they have Coca-Cola customized carbonated drink machines. So you can decide to get a little bit of cherry Coke, lime Coke, Coke Classic, etc. Skip one slide, and we're going to move to number 5, robotics and other types of sensing. And the use of robotics class is changing the way things are going. Less of us. Things are becoming more autonomous. Robotics allow for manufacturers to continue in 24 hours a day uninterrupted because it's replacing people. Sensors, our automatic sensors then, without people, can also detect problems immediately, and thus changes can be made relatively quickly. This concludes productions management. Now I want to talk about the second part of today's lecture, operations management. And remember, operations management just helps the entire operating process. It's sort of like the big overview of everything. So for the next several slides, we're going to look at things that operations management does. First, we're going to look at facility location. After that, we're going to look at the layout of the facility. Third, we're going to look at materials requirement planning. Fourth, we're going to look at purchasing. Fifth, inventory control. And finally, sixth, quality control. First thing we're going to look at is the facility location. And the facility location simply is the process of selecting a geographic location for a company's operations. Have you ever wondered why certain companies are located in certain areas? So for instance, why do you think that a lot of aerospace and defense companies are located in the Antelope Valley? Well, part of the reason is because there's a lot of open space to test their products and there's a lot of privacy. And that's part of the reason why you see both Northrop Grumman, Lockheed, and Boeing have locations in this geographic location. Given what's going on with the coronavirus, facility locations will come into question in the future. And as you can see, you're going to see more and more of telecommuting, working from home via computer as opposed to going into an office. Technology is allowing us to do this. So there may not actually be locations for businesses where you just have employees dispersed telecommuting from home. It'll be interesting to see how this plays out. The second thing we wanted to look at was facility layout. And facility layout simply is the physical arrangement of resources, including but not limited to people, to most efficiently produce tangible goods and provide intangible services. So the layout's going to depend on whether it's a service or a good. So if it's such thing as an intangible service, the layout will be in such a way as to assist customers find their products. If it's a goods, we're just looking to improve efficiency because customers usually won't be there at the place where we're making the goods. The next several slides, we're going to look at different layout options for facilities. The first one is an assembly line layout. Here, workers do only a few tasks at a time, and then it moves on to the next part. This is an example of an assembly line layout. Think of your traditional automotive manufacturing area here, where different people are gonna work along different areas of the assembly line, and that's all they're going to do. The second one is a modular layout. Here, teams of workers produce more complex units of the final product. So let's take a look at a visual example of a modular layout. And so you can see here, you still have groups of people here work together here, but you can see things can zigzag throughout. It's not just a straight assembly line from A to B. It can go in different directions. Third one is a fixed position layout. Under a fixed position layout, it allows workers to congregate around the product. In essence, the workers go to the product does not come to them. And so, for instance, if you look at this house, is a perfect example of a fixed position layout. All the workers come to the house to do their parts. So whether it's the finished carpenter or it's the architect or the general carpentry, they all go to the fixed position to do it. The final one is a process layout. In here, similar equipment and functions are just simply grouped together. So under a process layout here, anything that has to do with storage will be in one area. Anything that has to do with cutting will be in another area. So it's layout based on the different processes. The third thing we want to talk about under operations management is material requirements planning, and a newer thing, ERP, enterprise resources planning. First, material requirements planning, or MRP, are computer-based operations systems that uses sales forecasts to make sure parts and materials are available when needed. So, for instance, we want to have, for instance, if I'm making skis, I need to make sure I have those skis in the places that people are going to buy them. Or if I'm Home Depot, if there's going to be a hurricane, I want to make sure that wood and other types of lumber products will be available in such areas as Florida if a hurricane's going to hit. We're using sales forecasts to make sure things are done. A newer version of material requirements planning is known as enterprise resource planning, or ERP. ERP combines computerized functions into a single integrated software program. So such things within a company such as finance, human resources, purchasing, etc., are all put together into a single program. The fourth thing we want to talk about under operations management is the notion of purchasing. And simply, that's the search for high quality materials and resources by using the best suppliers and negotiating the best price for those goods and services, and to think how purchasing has changed via the internet and how you can get access to things that you weren't available to get before. Fifth thing we're looking at is known as inventory control. You want to purchase things, but you don't want to purchase too many things, because when you purchase stuff, the more you purchase, that's less money that you have for other things. So you want to purchase just enough stuff in order to produce your goods or provide your services. This is done through what's called JIT, or just-in-time inventory control. Under just-in-time inventory control, the production process where a minimum of inventory is kept and parts, supplies, and other needs are delivered just in time to get there to the assembly line. That way, we are not holding on stuff and our money's not being burnt on stuff that's sitting there. What if the stuff's sitting there and then a fire happens or another natural disaster and it's destroyed? We only need stuff when we need it just in time. So in order to have good just-in-time inventory control, it's essential that we have good coordination with the company's suppliers to get things just there when we need it. Finally, the sixth thing with regards to operations management is known as quality control. Under quality control is the idea of consistently and repeatedly producing what the customer wants, while more importantly, reducing errors before and after delivery. And companies have gone to this approach called Six Sigma quality. And it's a quality control measure that allows only 3.4 defects per million opportunities. So if you're making 1 million widgets, you can only have 3.4 of them, or between 3 and 4 of them, come up with deficiencies. Here's a visual example of the Six Sigma process. So companies try to make sure their operations are in order so that they have great goods and services, but in order to also promote that they have great production and operations management, we have such things as the Malcolm Baldrige Awards. As you can see here, companies can apply for awards in such areas as the ones listed here on this screen. Let's talk a little bit about ISO. I believe it's a question, essay question on your homework for Chapter 9. ISO stands for the International Organization of Standardization. So at first glance, you would look at ISO and think, why wouldn't it be IOS, since it's International Organization of Standardization? So why wouldn't it be IOS? It's actually ISO, and the reason why they call it ISO is because it's not an acronym. Thus, it comes from the Greek word isos, I-S-O-S, isos, which means oneness. Two types of standard ISO standards I want you to be familiar with: ISO 9000 and ISO 14000. ISO 9000 is a name given to quality management and assurance standards to make sure everything is standardized. So for instance, you want to be ISO 9000 compliant if you're making screws or bolts. That way you know that the screw or bolt is standardized and can be used anywhere in the world. When you're ISO 14000 compliant, it's more of best practices for managing a company's impact on the environment. Are you being sustainable? Are you reducing your carbon emissions or carbon footprint? Finally, I want to talk a little bit about PERTs and Gantt charts. PERT is an acronym for Program Evaluation and Review Technique. I believe this may be a question on your homework as well. PERT is simply a method for analyzing the various tasks involved in completing a given project, as well as estimating the time period to complete the project. PERT was developed in the 1950s for constructing nuclear submarines. So what are the steps involved in PERT? It's a 4-step process. The first step is to analyze and sequence tasks. And so what are the various tasks that need to be done? Once you've done that, step 2 says to now estimate the time needed to complete the task that you identified in step 1. Step 3 is visual. You draw a PERT network illustrating the first 2 steps. And then finally, in step 4, you identify the critical path. And simply put, the critical path is a sequence of tasks that takes not the shortest class, but the longest time to complete. And the reason why we want to make sure we have the critical path, because any delay along the path will cause the project to run late. So let's take a look at an example of a PERT chart for a music video. So remember, the first step was to analyze and sequence the tasks, and there are all the different tasks that are laid out in the squares. Remember, the second step involved was to estimate the time needed to complete each task. And as you can see by the arrows, you can see all the different time periods it takes to complete each task. Third is to actually draw this, which is what you see right here, the visual representation. And fourth was, remember, to identify the critical path. Remember, the critical path was the sequence of events that takes the longest time to complete. Well, class, if you look at what's in purple, that's the longest time to complete. It doesn't mean you don't do the things in light blue. It just means those things are all done at the same time. But the longest thing to complete here is what's in purple. And if you look here, the critical path for here, if we count all the weeks, would be 15 weeks. 1 plus 4 plus 2 plus 6 plus 1 plus 1. That's 15, or the critical path. Thus, any delay, if it takes, it takes longer than 15 weeks, the project's going to run late. Final thing I want to talk about are Gantt charts. Gantt charts are named after the person who created them, Henry Gantt. And it's simply a barred graph that shows what projects are being worked on, as well as how much has been completed at any given time period. I use these a lot when I'm trying to complete tasks. So for instance, we're going to look at a sample Gantt chart, in this case for a doll factory. Notice there are different tier bar graphs. So you can see, look, some of these things have to be done at the same time. So machine A has to be done during the 3 weeks. For 3 weeks it's scheduled here. You can see we've completed some of the work as denoted in white, and the stuff in orange is stuff that has to be done. And you can see sometimes I like to do this because there you have to do more than one thing at once. So you can see week 2 and 3, we got to work on both machine A as well as machine B. This concludes our lecture on Chapter 9, Productions and Operations Management.